6-1. Okay, 6-1 is on radical functions, which are, in this case, they're just going to be all square root functions. Okay, the first thing we're going to talk about is the domain of these kinds of functions. So remember, up until now, the only restriction that we've seen when we're talking about domain is if we have a function like this, right? That would give us a restriction because there's an x in the denominator and we wouldn't want that denominator to end up being 0, right? Because you can't have dividing by 0. Okay, now also when you have radical or square root functions like number 1 where you have f of x equals the square root of 2x minus 7. We're going to see another case where we have restrictions, okay? And the reason for that is you don't want what's underneath that square root symbol to be a negative, right? You always want, if you're taking the square root of a number, you want it to be positive, which means whatever is underneath this square root needs to be positive, and the way that we're going to say that is it needs to be greater than or equal to 0, right? That's how you're positive. If you're less than 0, then you're negative, right? That's what makes you negative, is being less than 0, okay? So what we need to do is say, okay, whatever is underneath this square root, which is 2x minus 7, needs to be greater than or equal to 0. In order for it to be in the domain. That's what's going to keep it positive. And then just solve that for that x, right? Which means the first thing I need to do is get rid of the minus 7 with the plus 7. So now I have 2x is greater than or equal to 7. And then divide it by 2. So now x is greater than or equal to 7/2. And that one's multiple choice. So what you're gonna, they're all 7/2. So what you just need to make sure you're looking for the correct symbol. It needs to be greater than or equal to 7/2. All right, the rest of these are graphing radicals, and they're all going to be multiple choice, or graphing just square roots. So let's look at let me show you first of all what just the standard square root graph looks like. Right, just the standard square root looks like that, okay? It's still going to have the same kind of shifting rules and things like that, but what we're going to do with these is put them in our y equals and then check some points. So on number 2, you have f of x equals 4 times the square root of x. All right, so let's get out our calculators and put that in our y equals. So just go to your y equals and clear it. So we're going to type in 4. Now the square root button, do you see how it's the x squared button, but right above it is the blue square root? So anytime you want to get to something that's above the button like that, you need to hit your second button first, right? That's what puts, it's like a shift key almost. That's what puts you in those blue functions. So second square root, and then type in your x, and then let's graph it. So what the 4 in front of that did to it was actually just kind of made that original square root, just made it steeper. That's what that 4 did, okay? So what we're going to do to graph this is let's get some points. How do you get points? You hit second and graph, right? So that's going to give you some points. Do you notice? Look what happens once you start getting where the x's are negative. It gives you errors in the y area. That's because that's not in the domain. That's not part of the graph, right? That's what that error means. So let's graph a couple of these points. So I'm just going to pick some out. I'll do 0, 0, 1, 4. 4, 8 is 1. All right, let's do those 3. All right, 0, 0 will be right in the middle. One, 4, so to the right one, up 4. And then 4, 8, which is to the right 4, and then up 8. Okay, so that's what your graph is going to look like. So this is multiple choice. Okay, now let me tell you something about these multiple choice graphs. If you'll notice on all of them, look at your x-axis goes by 2's to positive 10 and negative 10. Your y-axis, what does it go by? Goes by 2's, but it goes to 15. So that's what's making these graphs kind of seem off a little. Okay, we're used to seeing graphs where the x-axis and the y-axis both go to positive and negative 10, so it's kind of equal. Okay, so it's kind of hard to pick out which multiple choice graph it is because the x-axis and y-axis are kind of different. So you're gonna have to check for some points when you're doing your multiple choice looking. Okay, so looking at these on number 2. Okay, so again, the first thing you can do is knock out that A, right? Because it's upside down. Okay, the other 3 are the right shape, going in the right direction, but look at C. It's way flatter than this, right? It's like the original one. So when you're going between B and D, again, you'll just have to check some points. Look at where it goes through. Look for the point 1, 4 on the graph and see if that shape goes through that point. Or look for 4, 8. Okay, 4, 8 might even be a better one to look for since these graphs are going by 2's. You'll see the exact point at 4, 8 to see if the graph goes through it. So this one right here, it's going to be multiple choice like that. You won't have to graph it. You won't have to draw it out. Yeah. Okay. All right. Number 3. F of x equals negative 2 square root of x. So let's put that in our y equals. So the -2, and then hit your second button, right? Because that's what's going to get you to the square root. Square root x. Let's look at what that looks like on a graph. So what did that negative do to it? Flipped it upside down. That's right. Flipped it across the x-axis. So when you're drawing this one, or picking, there's only one thing it can be, right? If you're looking at the multiple choice, there's only one that's actually been reflected across that x-axis or flipped upside down. I'm going to go to second graph and get a couple of points, 0, 0, 1, -2, 4, -4. So 0, 0. 1, -2, so to the right 1, down 2. And 4, -4, which will be to the right 4 and down 4. So like you see, when you graph it, you can see when you plot points, you can see that it is flipped upside down like that, which would be A. And the good thing about 6.1 is there's absolutely nothing new from here on out. It's all doing the same thing. Plug it into your y equals, graph some points to get an idea of what the shape is going to look like. And then it's multiple choice from there. So let's look at number 4. Number 4 is going to look very similar to number 2, right? Because number 2 was 4 square root of x and this one's 5 square root of x. So they're going to be almost exactly the same. So again, I'm just going to y equals, clear it out, 5. And then again, there's your second. There's your square root, your blue square root. And put your x in there. And then graph it. So again, square root, but steeper, right? That's what the 5 did, was made it steeper. So second graph, let's get a few points. 0, 0, 1, 5. And 4, 10. All right, 0, 0. 1, 5. So to the right 1, up 1, 2, 3, 4, 5. And the last point, 4, 10. So to the right 4, up 10. So again, I would probably, since these graphs looks like they go by 2s also, you'll probably be able to narrow it down to 2 different graphs, right? It's probably either, well, no, it's not A, because that's the wrong shape, but it's probably B or D. I'm thinking probably D. But what you're doing is I would probably look for this point on the graph to see if it goes through it. All right, number 5. Oh, and that was D, if you're following along on the sheet of paper. All right, let's look at number 5. F of x equals the square root of x plus 7. right? Let's put that in our y equals. So the first thing you're going to do is you need the square root, right? So you'll hit second, then your square root. Underneath the square root, you'll type in x plus 7, all under the square root. Let's graph that. So think about your transformation rules. This is an inside number, right? It's inside the square root. What do inside numbers do? They shift you horizontally, and you go opposite the sign. So where is this plus 7 that's inside going to shift me? You'll notice, look at your graph. It's the square root graph shifted to the left 7, right? That's what this is. This gave me the square root graph, but it shifted the start of the square root to the left 7 because of that plus 7 on the inside. Okay? Go ahead.
So why does this one have positive?
Oh, okay, I see what you're saying. So, okay, let's graph this, and then I'm going to show you how that relates. Okay, I will show you exactly. I think I can answer that question by, let's get some points on this. So second table. So let's see, 2, 3. Negative 3, 2. If I keep going up in my negatives, I got negative 6, 1, negative 7, 0. But look what happens when I go farther negative after 7. It starts giving me an error message. So let's plot these, and then we'll talk about why you can have some negatives, numbers. So let's look at this. So let's see, 2, 3. So to the right 2, up 3. Negative 3, 2, which would be to the left 3 and up 2. Negative 6, 1, so to the left 1, 2, 3, 4, 5, 6 and up 1. And negative 7, 0. So to the left 7 and then up and down 0. So it's right there on the x-axis. So there's what it looked like. So that would be this square root graph. And look, where it started, it was shifted to the left 7. So so we're talking about the domain here, right? Now, it doesn't say x can't be negative. It says this has to be, the whole thing under there has to be positive, which means x plus 7 needs to be greater than or equal to 0. So if you're solving to find this domain and solve for x, you'd have to subtract the 7 from both sides. So x needs to be greater than or equal to negative 7, okay? Which you'll notice what happened in your calculator when you went below negative 7. What did it start giving you when your x was below negative 7? When it came to negative 8, it was error. That's because this graph doesn't go past negative 7. Once you get the x's being negative 8, which will be right here, that's not on the graph. That's why that's why these numbers are not a part of the x's, or in other words, a part of the domain, right? Because the domain are your x values. So you can have negative numbers for your x's as long as they don't turn that whole thing right there negative. That's why all the x's have to be greater than negative 7, because once they get below negative 7, that's what starts giving you that error, because it's not part of the graph. It's not in the domain. Yep, this right here does. Yep, yep. All right, number 6. (15 plus 3x), the square root of 15 plus 3x. All right, let's find some of these points. Go to your y equals, clear it. Okay, all these multiple choices on number 6 are so different from each other. You're going to be able to tell once you put it in your y equals which one of those it is, right? They're all a completely different looking graph. Okay, so just make sure you do second square root. Under that, you're going to have 15 plus 3x. And graph it. So remember, this right here, just finding the domain is going to kind of show you what the shape is going to be. This right here, 15 plus 3x, is going to need to be greater than or equal to 0. So when you solve it for x by subtracting the 15, you're going to have 3x is greater than or equal to negative 15, and then divide it by 3. So x is going to need to be greater than or equal to negative 5. So what is that telling you? When you go to your table, second table, look what happens at negative 5. Negative 5 works. But what does negative 6 give you? Error, right? Because the negative 6 is too small. It's not good enough. If you put a negative 6 in here for x, it's going to make this whole situation in here negative, which that's what you can't have. Okay, so let's see. Some points are negative 5, 0, negative 2, 3, and 7, 6. So negative 5, 0, 1, 2, 3, 4, 5. Negative 5, 0. Negative 2, 3. So to the left 2 and up 3. And then another point at 7, 6. So to the right, 1, 2, 3, 4, 5, 6, 7. Up 1, 2, 3, 4, 5, 6. Okay, and if you're looking at your graphs on number 6, there's only one that even goes in that direction, which would be C. All right, the last one. I told you this section was short and sweet. G of x equals the square root of 7x minus 8. So again, go into y equals, clear it out. Second square root, 7x minus 8. Let's graph it. Okay, I am going to get some points, but it looks like the only ones that you're even in competition to be the right answer would be C and D. Okay, a good thing to look at is, look where this touches the x-axis. It's on the right side of the origin, right? This right here, look at C and D. Where does C touch the x-axis? On the left, right? If you're looking, it touches it on the left. This is the only one that has the right shape and touches the x-axis on the right. Okay, but again, just to practice the graphing, oh. Oh, they're not gonna be any good points. Just have to get close. All right, I'll just do a couple that are close. So one's an error, which means one's just not in the domain. One would make what's underneath here negative, so that's why it's not in there. So let's start with 2. 2 will be at 2.4495. 3. Yeah. And 4 would be at 4.4721. So again, these are obviously not going to be exact points, but it'll give you the shape. Okay, 2 to the right 2 and up about 2.5-ish. So to the right 2, up 2.5. 3, 3.6. So to the right 3, up between 3 and 4. And to the right 4, up about 4.5. Okay, now it is a square root graph, so this is going to continue down until, you know, you can tell on here, it looks like it crosses it really close to, it looks like it comes down to the x-axis really close to 1. Okay, which means that answer would be the D. Okay, so that is all for college algebra today. I am going to start the support class a little early today because we do need to do I'm going to do support for 6-1 and for 6-8. Okay, because we do have 3 support sections to cover this week, and support doesn't meet on Fridays, which means at some point we're going to have to do 2. So we're going to do it today since we have so much time. Let me take roll real quick. All right, Chora, Hines.
Miss Hanson, I'm here.
I got you. Bracia Clark, I got you. Sharonda Hurst, I got you. Xavier Weimer, I got you. Santiago, I got you. Prashana, I got you. Crystal, I got you. And Grant, I got you. Okay, just go say your last name around the room now. I got everybody online. Ellis, Stacy, Bro, Hauser, Todd, I got you. Ecker, Payless. Okay, all right. Give me 5 minutes because I'm going to make sure everybody in here has the quad program on their calculator if they want it. So I'm going to start support in 5 minutes.